Let's go from here. Okay, so we have this equation y equals x squared minus 6x plus 8. Now, they didn't tell us what it is. They said find the vertex and intercepts, but I think it should be obvious that this is a parabola because it's a quadratic equation, but only the x is squared and the y is not. And we know that when we have that, we get what's called a parabola, which is that U shape that we discussed the other day. And the a in this case, the leading coefficient happens to be 1. The b is -6. And the c is 8. And we know by looking at the a, this means that it's an opening up parabola. Remember, we had that hint. A is positive, means you're in a good mood. So you have a smile on your face, it opens up. We also have this rule to find the vertex of the parabola. We find the x of the vertex by doing -b over 2a. And in this case, that will mean that we're doing the b is -6 over 2 times 1, because the a is 1. And therefore, this gives me +6 over 2, which is 3. That is not the whole vertex, because the vertex is a point. So not only do we need an x value, we also need the y value. And we find the y value by substituting this value of x back into the original equation. So we're going to do, here's my x squared, so it's 3 squared, minus 6 times 3 plus 8. And this gives me 9 minus 18 plus 8, which is -9 plus 8, which is -1. So the vertex happens to be the point 3, -1. So in order to find the vertex, all we have to know is know this formula, x equals -b over 2a, and then stick it into the equation. By the way, in the near future, I will be sending you out a study guide sheet in which I'll put in all the important facts and all the important formulas for this term, together with examples, so you can use it as a review for the course. Again, we are now at lesson 24. We have a total of 28 lessons. So after this, we have just 4 more lessons, 2 full weeks. Don't forget that next Thursday, which is Thanksgiving, we do not have class. So we have class 1 day next week. The following week after that, after Thanksgiving, we have 2 lessons. And then we have 1 lesson the Tuesday the following week. And our final will probably be sometime like Wednesday, Thursday, or Friday of that second week after Thanksgiving. So we're getting very close to the final, and it's time to start reviewing. And that's what I'm going to be doing with you as we go along. But we still have 2 topics that we're going to do, and then we have to review. Okay, so let's go back to this. We found that the vertex of our parabola was 6, -1. It also asked us to find the intercepts. So how do we find the intercepts? Let's go over here. So there are 2 types of intercepts. There's the y-intercept, and there are the x-intercepts. And if you recall what I said on Tuesday, there's always one y-intercept. And we find it by replacing x with 0. In your equation, put the wherever you see an x, put a 0. Of course, that'll make this 0 and this 0, and you're left with just plain y equals 8. I think I gave you that as a hint also. The c, the number that stands alone, that's not attached to any variable, that is your y-intercept. If we wanted to be more elaborate, we could say the y-intercept is the 0.08. It's enough to say the y-intercept is 8 because you know it's on the y-axis. But the true way to say it is 0.8 because it's a point you should give its x and y value. To find the x-intercept, we do just the opposite. Instead of putting the x equal to 0, we then set the y equal to 0. And when I set the y equal to 0, that gives me 0 equals x squared minus 6x plus 8. And that gives us a quadratic equation to solve. And we know that there are 3 ways that you can solve a quadratic equation. You can try it by factoring, though it doesn't always work. You can try it by completing the square, though that method would always work, but if you don't have the right conditions on it, you can get stuck into bad fractions. The method that always works is a quadratic formula, but this happens to be easily factorable, so we may as well use the factoring method. X squared is x and x. The last term is positive, means both signs are the same. Middle being negative means they're both going to be negative. And we're looking for 2 numbers that are going to multiply to this 8. And since this is positive, they have to add to the 6, which is 4 and 2. And then we set each of these equal to 0. X minus 4 equals 0. Will give me x equal to 4. And x minus 2 equal to 0 will give me x equal to 2. So our 2 x-intercepts, and that's the most common situation, is that you will have 2 x-intercepts, are 4, 0 and 2, 0. And with this information, you could very nicely draw the graph of the parabola. I'm going to do it right over here because that's where I have some space left. Whenever I want to draw the parabola, the first thing I go to is my vertex. My vertex is 1, 2, 3, down 1. We also mentioned that it's going to be an opening up parabola, but let's just put in these other numbers. The y-intercept is 8, so here's 1, 2, 3, 4, 5, 6, 7, 8. Here's my y-intercept. My x-intercept are 4, 0, 1, 2, 3, 4. Here's 4, 0 and 2, 0. And I get something that looks like this. And of course, it looks the same on this side as it does on this side. And there's our sketch of our parabola. It's that U shape. Again, the sides keep opening up wider, but this is what in any one question on the final, they won't ask you to do all of these things. They might just ask you to draw a sketch. They'll give you a sketch to pick out the right one. In that case, the most important thing to do is to find the vertex and decide whether the parabola opens up or down. Because once you have its vertex and you know that it opens up, if you don't get it exactly right where it's crossing the axes, that's still, you're going to get the right, you'll be able to pick the right choice. It might ask you not for the vertex, it might ask you what are the x-intercepts. So then you'd have to do this. It's unlikely that you would have to do all this work. Okay, does anybody have any questions? Okay, I had given you some homework Is there anybody who wants me to do any of those? I did give you answers on your sheets. Is there anybody who wants me to do them? If not, then I'm going to go on to new material. Okay. So this is just the end of Chapter 9. Chapter 9 is what we call conic sections. We discussed what the graphs of different quadratic equations would look like. We saw it wasn't just one shape. We got 4 possible shapes called the circle, the ellipse, the hyperbola, and the parabola. And we discussed how we would go about. Again, we just talked about the simple ones. We didn't go into very complicated ones, but we talked about how to get the graphs of those 4 types of conic sections. Okay, so I'm now erasing this. Don't forget to look on Delta Math again. I did find some questions about circles. Again, there weren't good questions about the parabola or the ellipse or anything like that. So I just gave you some questions on circles and how to find the center and radius of a circle. So far in the term, we've talked about 2 types of things. We've talked about algebra, how to solve equations, how to factor, how to add, subtract, multiply polynomials, both how to solve linear and quadratic equations. So we've done that. We've done a lot of algebra. We've also done what we call some geometry. Geometry has to do with shapes. We talked about graphing, and graphing has to do, it's a combination of both algebra and geometry because it talks about equations of lines or circles, etc. But it also, we drew the shapes. So that was geometry. We're now going to go into a 3rd branch of mathematics called trigonometry. And the word trigonometry sort of gives you a hint as to what we're going to be studying. The TRI at the beginning, tri, is a prefix that means 3. 3, we're dealing with shapes with 3 sides, in other words, triangles. Metry means measurement, from the word meter. So we're talking about how to measure different things in a triangle. And specifically, we're going to be talking about right triangle trigonometry. Trigonometry itself is a topic that you can spend months studying. We're just doing an introduction to this. We're going to introduce the use of certain words, certain definitions of different things, something like a sine, a cosine, you might have heard those terms before. And we're going to figure out how to find those things. Again, this is just an introduction, so we don't go too deeply into it. Let's start at what we mean by a right triangle. A right triangle, this is not right. This is not too good. It's a right triangle. I'm going off to that. It should go straight across. Let's call this A, B, C. Is a triangle in which one of the angles is what we call a right angle or a 90-degree angle. And a 90-degree angle happens to be a very important type of angle because it's wherever you see a square corner, what you're looking at is a right angle. And if you look at your room that you're sitting in right now, you'll see your doors, unless it's a very fancy type of door, a regular door, the corners are right angles. You look at your bed. Again, if it's a regular bed, the corners are right angles. The room usually meets at right angles. Windows are usually right angles. So we see that, or this board right here, the corners are all right angles. It is a basic building block that we use in most cases to make things. So it's a very important angle. The board here is not a triangle, it happens to be a rectangle. If we would draw what we call the diagonal, go from one corner to the opposite corner, we would get a right triangle. In other words, even a rectangle, its basic building block is a triangle. So if we want to talk about, and you can't talk about a closed figure with less than 3 sides. If you only have 2 sides, you're not going to get any kind of figure. So a triangle is your most basic building block, and a right triangle is, again, basic to those basic ones. So that's what we're going to be talking about here. A right triangle, a triangle in which one of the angles is a right angle. Now, you may remember from previous courses, if you add up all 3 of the angles in the triangle, all 3 add up to 180. So in this case, if one of your angles is 90 degrees, the other 2 have to also add up to 90. So if I, for example, know that angle B is 35 degrees, then this will have to be 55 degrees because 35 and 55 add up to 90. And if you add all 3 of them together, you're going to get 180 degrees. So that's number 1. You have this right triangle, and the angles of the triangle are usually quite easy to figure out. All you need really is to know one angle other than the right angle, and of course you have all 3 angles. What we're more interested in trigonometry is the sides. And before we actually go into trigonometry, we're going to talk about how to figure out the sides of a right triangle. First of all, we call this triangle, its name is ABC. We use capital letters at each of the angles, and if we want to give the name of the triangle, it's going to be using all those capital letters. If you use okay, Pertana, got it. So the 3 capital letters that are at what we call the vertices, the corners of the triangle, are what we use to name the triangles. We always name the triangle using capital letters. Now, and we call this angle angle A, this is angle B, and this is angle C. If you're using just the letters A, B, and C, it's most likely that the C is going to be your right angle. It doesn't have to be, but that's the most common way things are done. Now, when it comes to giving the names of the sides, let's say I wanted to talk about not the angle A or the angle C. What if I wanted to talk about the side that starts at A and goes to C? Obviously, I could call that AC. And you might have seen that done. Doing AC with a little line above it means we're talking about the line that's starting at A and ending at C. It could also have been called CA, because it doesn't matter where you start and where you finished. But it gets a little complicated. With the angles, you only have to put in one letter. But with the sides, this way you have to put in two letters. So what is sometimes done is, instead of using capital letters, we use lowercase letters, and we use the lowercase letters to indicate the sides. In other words, if capital A is an angle, lowercase a is going to be the side. And there's a specific way in which this is done. If this is angle A, and there are three sides in my triangle, two of the sides of the angle are part of the triangle. There's a third side, a side that's across from angle A. It isn't attached to the A, but is across from it. That's what we call lowercase a. Similarly, this is angle B. Across from it is this side. This is lowercase b. And if this is angle C, across from it is this side. And that's called lowercase c. So we're using the lowercase letters for the sides, the uppercase or the capital letters for the angles. By the way, the side that's across from the right angle is given the name hypotenuse. If I talk about the hypotenuse of a right triangle, I'm simply talking about the side in the triangle that is right across from the right angle. Notice I made this little square corner to indicate that that's the right angle. The two other sides of the right triangle, the ones that are not the hypotenuse, are called the legs. So there's leg B, and there's leg A, and there's hypotenuse C. This is just, again, introduction, probably things I've heard of before. Now, there's one important rule that actually goes all the way back to Greek times. It's something called the Pythagorean theorem. And it's named after a Greek mathematician called Pythagoras. You don't have to remember that, but that's why it's called the Pythagorean theorem, because it's this Greek mathematician came up with this idea as the first one. And that is that in the right triangle, a squared plus b squared will equal c squared. Anytime you have a right triangle, if you square the two sides that are the legs, you multiply them each by itself and add them, that'll be you'll get the same number as just doing the hypotenuse squared. Now, how does this help us? This helps us because once you know two sides of a right triangle, you can always figure out the third side using this formula. For example, suppose I give you a picture of a triangle that's a right triangle. We'll note right triangle here. And they tell me this side is 2 and this side is 5. And they want me to find the hypotenuse of this right triangle. So I like to always label this. This is going to be my C. I usually put the A on the bottom and the B on the top. That's the way I usually do it. You don't have to do it this way, but that's how I usually do it. The C at the right angle, the A at the base, and the B at the peak, which means that this is my small a, because it's across from capital A. This is my small b, because it's across from capital B. And this is my C. And I asked you to find the hypotenuse, which is C. So I use this formula, a squared, which is 2 squared, plus b squared, which is 5 squared. That's going to give me my C squared. Well, 2 squared is 4, and 5 squared is 25. So that gives me that C squared is 4 plus 25, which is 29. Don't take the square root until you've added them together. These two add up to 29. That's what your C squared is. So if you want what C is, you have to take the square root. We've done this. If we had x squared equals a number, we found x by taking the square root. So C is going to be the square root of 29. Now notice, usually when I'm solving a quadratic equation, if this would have been an x squared and it said x squared equals 29, my answers are either positive square root of 29 or negative square root of 29. But since the C represents the side of a triangle, and a triangle can only have positive sides, it doesn't make sense to say something measures negative whatever. So we use only the positive answer. The square root of 29 is the answer in radical form. Now, sometimes we don't want the answer in radical form. You'll know by the nature of the answers or the nature of the question. If it'll say, give your answer in that radical form, you could just leave it like this. If it says, give your answer, for example, to the nearest 10th, that means I have to go on my calculator, and you must have a calculator. We're going to be using a calculator quite a bit from now on. So I go to my square root button, and I go to 29, and I get 5, I see something like this, 5.385164807. It stops here, but really that's only because there's no more space in my calculator. The square root of 29 is an irrational number. It's a non-ending, non-repeating decimal. If I want this to the nearest 10th, I look over here. The 3 is in the 10th position. The number after it is an 8. So I'm going to have to round this off to 5.4 if I want my answer to the nearest 10th. If I had wanted my answer to the nearest 100th, I would stop at the 8. The next number is a 5, so I would have given you 5.39. So I can, depending on how accurate you want your answer, again, it'll depend on the way the question is worded. Okay, let me give you one to try while I take attendance. I'm going to give you a little harder one because I'm going to not draw the picture. I have my right triangle ABC. And again, C is the right angle. So you can draw it. Small a is 7. And small c is 12. I want you to find B, both as in radical form and to the nearest hundredth. Remember, hundredths means 2 decimal places. Okay, I'm going to give you a few minutes to try that while I take attendance. Get started again. Okay, let's draw this picture. And again, I'm going to put my A here, my B here, and my C here. Here's my right angle. And again, I'm going to call this my small a because it's opposite the capital A. This is my small b because it's opposite the capital B. And this is my small c. And I was told that the A is 7 and the C is 12. And we wanted to find the B. Now, it's a little bit different because I gave you the C. But again, the formula is A squared plus B squared equals C squared. And I fit it in. 7 squared plus B squared equals 12 squared. And I'm going to keep my calculator handy because it's going to be of use. 7 squared is 49. And 12 squared is 144. So I'm going to have to subtract 49 from both sides to get the B squared. This will give me that B squared equals 144 minus 49, which is 95. And that means that the B has to be the square root of 95. I don't even think that we can simplify it because the only thing that we could get to that multiplies to 95 is 5 and 19. Neither of those are a perfect square. So in radical form, my answer is the square root of 95. Again, if you could, and you want it in radical form, you should simplify the radical. So that was answer number 1. Answer number 2, it said give the answer to the nearest hundredth, which means I have to use my calculator. So I do the square root of 95, and I get 9.7467. I'm not even going to put any more numbers. I want it to the nearest hundredth, which means I want to stop at this 4, but the number after the 4 is 6. It's 5 or more. So rounded off, this becomes 9.75. So this is my answer in decimal form rounded, and this is my answer in radical form. So what this has shown us is that I only need to know 2 sides of my right triangle, and it doesn't matter which 2 sides I know, I'll be able to figure out the third side using this Pythagorean theorem. Okay, so now we can go on to actually trigonometry. And basically what you have to know in trigonometry is 6 terms. There are 6 trigonometric functions, 6 trigonometric values that you can get from a right triangle. And they all are ratios of 2 sides. There are 3 major ones, and there are 3, I'll call them minor ones, not as important. You still have to know them, but they're not used as much. Let's first talk about the three primary trigonometric functions. I'll give you their names. I'll then show you how to find them in a right triangle. The first one is something called the sine, S-I-N-E, but it's abbreviated S-I-N. If you look on your calculator, actually, I'll show you on my calculator, there is a button that says S-I-N. That's the trigonometric button that has to do, because there's a lot of things you could do with this sine. There's something called the cosine, which is abbreviated COS. And then there's something called the tangent, which is abbreviated TAN. If you notice, the abbreviations are simply the first three letters of each name. Each one of these is a fraction. Now it's a fraction, but you remember a fraction, if you could change the fraction into a decimal. But by definition, these are all fractions. Let's take a standard right triangle and discuss, define what we mean by the sine, the cosine, and the tangent. So here's my standard right triangle that we've been using all along, where we put the A at the base, the B at the top, and the C at the right angle. And again, this is the small a, this is the small b, and this is the small c. I don't know what the exact sizes of these sides are, but these are the names of the sides. The sine of A. Now notice, I'm always going to say sine, and then I'm going to, right next to it, put a letter that will be either the angle A or the angle B, because these numbers depend on the perspective you're looking for. So I could talk about sine A, I can talk about sine B. I usually don't talk about sine C. The right angle is usually not involved in it. We're usually interested just in the sine or cosine or tangent of what we call the acute angles, the angles that are not the right angles. But it's not, you can't just say, what's the sine? You have to say, what's the sine of, and then give the name of the angle you're looking at. By definition, the sine is the opposite side or the opposite leg over the hypotenuse. What does that mean? Here is my angle A. In terms of angle A, obviously the C is the hypotenuse. I'm going to call it H. I'll put a H with a box. The hypotenuse is the one that's across from the right angle. But the other two sides are legs, and one is across from angle A, and one is next to angle A. The one that's across from it is called the opposite. Let's call it O. You know what? Let me call this HYOP. I'm going to use two letters because I don't want you to get it mixed up with the letters that I'm using. I'm just using it as names. The side that's next to the angle A, that's attached to angle A, is what we call the adjacent side. Adjacent, when something is adjacent to something it's next to. So this side, this angle B, is the adjacent side. So when I want to find the sine of angle A, I have to know the sides of the triangle. And all I have to do to find sine angle A is to locate the opposite side, locate the hypotenuse, and make a fraction of the opposite side over the hypotenuse. Let's just write SOH. Sine is opposite over hypotenuse. In other words, in terms of the letters that I have here, the sine of angle A will be small a over small c. Because the sine is the opposite over the hypotenuse. That's our first trigonometric function, our first trigonometric value. Our second one is the cosine. Again, just like with the sine, I have to write not just plain cosine, but I have to write cosine and then the name of the angle I'm looking at it, from which perspective. Because remember, these are opposite and hypotenuse and adjacent. We have to know from which perspective are we looking at this. It turns out that the cosine of A is also a fraction that you get by doing the adjacent leg over the hypotenuse. In other words, if you want the cosine of angle A, here's angle A, its adjacent is B, and again, the hypotenuse we have from before is small c. It's the fraction that we get by putting the adjacent leg over the hypotenuse. Let's remember that by saying cosine is adjacent over hypotenuse. Our third primary trigonometric function is something called the tangent. And again, just like we did the sine of A, the cosine of A, we're going to have to again say tangent. And again, we're going to have to write what angle we're talking about. Tangent A is what's called the opposite leg over the adjacent. In other words, if I want the tangent of A, I have to go to the opposite side, which is A, and put it over B, which is the adjacent side. In other words, tangent A is A over B. So all three of these are just fractions that you get by dividing one side of the triangle by the other. You just have to know which sides to divide by which sides. Remember, tangent, we said, is opposite over hypotenuse. So let's write tangent is opposite over hypotenuse. And this thing I just wrote now, which we read SOHCAHTOA, is what's called a mnemonic device. A way of remembering, because that's the important thing here, the way of remembering what is the sine, what is the cosine, and what is the tangent. I always try to think, you know, mnemonic device is something that helps you remember, and you help remember better if you have a picture of something in your mind. So I picture somebody coming in from a freezing cold day like today, And their feet were so cold because they weren't wearing their boots. So they put their feet in a tub of hot water and they soak toe. So picture somebody soaking their feet in a pot and a pail of water, and that'll help you remember that the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Okay, let's see how this works out in actual examples. Okay, so I'm going to erase most of this. I'll leave that SOHCAHTOA on the board because that's our mnemonic device and that we have to remember. And I'm going to show you how to work such a problem out. So I'm taking an example off a previous final. Suppose they gave me a triangle that looks like this, where they say this side is 3 and this side is 7. Now, usually they would put A, B, and C on it. So sometimes they do A, B, C, like we've been doing. Sometimes you'll see something like this. It looks like a 0, but it's not. It's a 0 with a line across. It happens to be a Greek letter. We use Greek letters for trigonometry to name angles. So instead of calling this angle A, we can call this angle theta. This is the Greek letter theta, Theta, theta. It's like they're calling the hurricanes by Greek letters now. The reason we use Greek letters for trigonometry is because trigonometry was first thought up by the Greek mathematicians, so we can use Greek letters. The advantage of it is whenever I see a Greek letter used in trigonometry, I know that the letter represents an angle. We never use Greek letters for the sides, we only use it for the letters. So again, I could have given the picture this way, or I could have been given the picture this way, where I call this A, B, C, and this would be my 7, and this would be 3. In other words, angle theta and angle A are the same thing. This is using capital letters, this is using Greek letters, but the idea is the same. The question here is to find cosine theta. Okay, so we're going over here and we want to find cosine theta. So how do I find cosine theta? I remember my mnemonic device. SOHCAHTOA. Ka. Ka is cosine. It's adjacent over hypotenuse. So I go to my triangle and label the sides according to angle theta, which is the opposite, which is the adjacent, and which is the hypotenuse. Now, if this is angle theta, the one that's straight across from it is the opposite side. The side that's attached to it, that's not the slanting one, that's not the hypotenuse, this is the adjacent. And obviously, this is my hypotenuse. The hypotenuse is the one that's always across from the right angle, which you'll always recognize by that square corner. Well, if I want to find cosine, and I want to do adjacent over hypotenuse, I know what the adjacent side is. I see it's 7. But what I don't know is the hypotenuse. I only know the opposite. So I have to use the Pythagorean theorem to figure out the third side of the triangle. So here's what we do. We do a squared, which is 3 squared, plus b squared, that's 7 squared, equals c squared. We use our Pythagorean theorem to figure out the third side of the triangle. This 3 squared is 9, 7 squared is 49. That's what c squared is. So c squared equals 58. And c is the square root of 58. Now, I can't simplify the square root of 58. It actually said they want the answer as an exact answer with a rational denominator. Now, the first thing I look at, this is in radical form. 58 is not a perfect square, so I can't change it to a regular number. Also, I can't even simplify it because the only thing that 58 multiplies into is 2 and 29, neither of which is a perfect square. So therefore, the hypotenuse has to be the square root of 58, which means that the cosine of theta is 7 over the square root of 58. This is basically the type of questions you're going to have to be able to do. Can you figure out the 3 sides of the triangle? Do you have 2 of them so you can figure out the third one? And then do you remember, what does the sine stand for? What does the cosine stand for? What does the tangent stand for? Now, it turned out that we got cosine theta is 7 over the square root of 58. But you may remember that we said we don't want to leave a radical in the denominator. And it even said we want a rational denominator. We want to rationalize the denominator. And what we said is when the denominator is a single term, we just multiply top and bottom by the radical. If the denominator is a binomial, let's say it was 2 plus the square root of 58, then we'd have to use the conjugate. We don't use the conjugate here because it's a single term. I will multiply the denominator by the square root of 58. But of course, whatever I do to the denominator, I do the same thing to the numerator. And that gives me 7 on top, radical 58. And the square root of 58 times square root of 58 is 58. And that's the answer that they wanted. So it's just a matter of knowing the terminology and being able to use the terminology to determine what we're looking for. Do you think you're ready to try one on your own? Everybody okay with this? Okay, so let's do an example. Let me draw it here. Now, given this example, again, here's my ABC. Here's my right angle. This side they're calling 3. This side they're calling 5. And this is the angle they're calling theta. They're not calling A the theta now, they're calling this the theta. And they want me to find the sine of theta. They could have also said sine of B because they use both types of letters. So sine B, if you want to use the American or the regular alphabet, sine theta if you want to use the Greek letter, but it's the same angle. It's this angle over here. Okay, I'm going to stop for a couple of minutes and give you time to figure this out. Okay, let's see if we can work it out. I'm going to do it over here. Since this is my angle theta, I'm now going to label my sides. The side that's opposite theta is the 3, because it's the one that's across from it. That's why we have to be very careful about writing which angle we're doing the sine, the cosine, or tangent of, because it's going to be different depending on the location of the angle. So I have to know the location of the angle. B, or theta, is up here, so the opposite is the one that's across from it is over here. This one is the one that's attached to it. This has to be the adjacent. I'm really supposed to put the box around the word adjacent. And here's my hypotenuse. The hypotenuse always stays the same. The hypotenuse is always across from the right angle. Now I know that the sine is so opposite over hypotenuse. It's opposite over hypotenuse. So it's going to be the opposite of theta, which is the 3, over the hypotenuse. But we have the same problem. I don't know what the hypotenuse is. So just like I did before, I'm going to have to use my Pythagorean theorem to figure out the third side of the right triangle. Anytime I have 2 sides, I can always figure out the third side. Again, it's a squared plus b squared equals c squared. So it's going to be 5 squared plus 3 squared equals c squared. 5 squared is 25. 3 squared is 9. Don't take the square root until you add them. So we get that c squared is 25 plus 9, which is 34. So c has to be the square root of 34. Notice it's not the square root of 25 plus the square root of 9. You have to add them and then take the square root. So this becomes 3 over the square root of 34. Again, if they want it in rationalized, we'd have to multiply by the square root of 34 over the square root of 34 to get 3 radical 34 over 34. You can't reduce this or anything. Here is your answer in rationalized form. So that's how we go about finding one of the trigonometric functions. We have a few minutes left. I want to now talk about the other 3 trigonometric functions, the ones that I call the secondary functions. Okay, so let me erase this. Anybody have any questions before I go on? Okay. Let's remember what we said. We had sine, call it sine theta, cosine, and tangent as our 3 primary trigonometric functions. Remember, the sine is opposite over hypotenuse. The cosine is adjacent over the hypotenuse. and the tangent is opposite over adjacent. Again, each one of these is a ratio of two sides of my right triangle. What are the other three trigonometric functions that we talk about? Well, there is something called cosecant, C-O-C-E, which is abbreviated CSC. I can't abbreviate it COS because I'm already using COS for cosine. So we abbreviated CSC. The cosecant of theta is the reciprocal of the sine. If the sine is opposite over hypotenuse, the cosecant is hypotenuse over opposite. In other words, if I tell you that the sine of an angle is 3/5, then its cosine is its cosecant is 5/3. It's just the reciprocal. Each one of these new trigonometric functions, the secondary ones, are simply one of the others turned upside down, the reciprocal. The second one that we talk about is something called the secant, which we're going to abbreviate SEC. This is not a problem because we can use the first three letters because it hasn't been used before. The secant is the reciprocal of the cosine. In other words, since the cosine is the adjacent over the hypotenuse, the secant is the hypotenuse over the adjacent. And the last one is called the cotangent, which is abbreviated COT. The cotangent, is the reciprocal of the tangent. The tangent is opposite over adjacent, so the cotangent is adjacent over the opposite. Now, I'm not going to give you another thing like SOHCAHTOA to remind you because it'll get too confusing. These are easy to know. If you know what the sine, cosine, and tangent are, you should be able to figure out the cosecant, the secant, and the cotangent because they're simply the fractions turned upside down, the reciprocal of the fractions. The question is, how am I going to remember what goes with what? How do I know that the cosecant goes with the sine? Well, I'm going to give you my method of remembering. Obviously, the tangent and the cotangent, nobody has a problem. It makes sense that the cotangent is the reciprocal of the tangent. If it's going to be the reciprocal of anything, it's the one that it sounds the most like. The cotangent and the tangent are reciprocals. The question is, how am I going to remember that the sine and the cosecant goes together? So this is what I remember. Notice in each of these pairs, one starts with an S and one starts with a C. So sine starts with an S, so its pair has to be the one that starts with a C, which is the cosecant. In this, the cosine, it starts with a C, so its match has to start with the S. That's why C goes with S, C goes with S. Remember it that way. Or co with not co, something of that nature. This is sine, this is cosecant. One has a co, one doesn't. That'll be how you remember it. So let's look at what kind of any question you could be asked on something like this. I'm giving a picture that looks like this. And I want to find the secant of this angle, this theta. Okay? Now, how do I do that? I first decide what is secant. Now, secant is one of what we call the reciprocal functions. It's not sine, cosine, or tangent. It's not one of the primary ones. It's a secondary one. So I have to think, what does secant go with? Secant, it starts with S, has to go with the one that doesn't start with S, the one that starts with C. So it has to go with cosine. In other words, it's the reciprocal of the cosine. Once I know it's the reciprocal of cosine, and the cosine is adjacent over hypotenuse, that must mean that the secant is the hypotenuse over the adjacent. So that's my thinking. So now I go to my triangle. Here's my angle. This side is opposite, obviously the opposite because it's across from the angle. This is my hypotenuse because it's across from the right angle. So this is my adjacent, the one that's attached to the angle, but not the hypotenuse. And I need to know the hypotenuse, which I have, it's 13, over the adjacent. How am I going to figure out what adjacent is? What I did before. I'm going to use my Pythagorean theorem. I'm going to do a squared, 12 squared, plus b squared. This is my b squared, equals c squared. That's my 13 squared. So I get 144. Just want to make sure I'm not going into the out of the picture. Plus b squared equals 169. Subtract 144 from both sides. That'll give me, let's go over here so we have some space. B squared equals 169 minus 145, which is 25. Now 25 is a perfect square. We know that B then is the square root of 25, which is 5. So the adjacent side on this triangle is 5. So if I want to figure out what the secant is, I did the hypotenuse, which was 13, over the adjacent, which is 5. And my answer came out to 13 over 5. And that's how I would do it. I'm going to post some homework like this on Delta Math so that you can work on these. We'll finish this topic up because really we've done most of this topic already. By Tuesday, you must know SOHCAHTOA. That's your main homework. To know the definitions. What is the sine, the cosine, and the tangent, which you can remember from SOHCAHTOA. And what are the cosecant, secant, and cotangent. And you should be able to do these type of problems. There isn't really too much else that you have to know on this topic. Again, we just touched this topic of trigonometry, even though there's many, many more aspects to it. This is what you'll need to know when you go into any other course that teaches where you need to know trigonometry. Okay, I'm going to stop right now. Just remind you that next Thursday is Thanksgiving, so we do not have class. So we have, and I'll reiterate what I said at the beginning of the course, of the class. We have one class next week on Tuesday. The week after Thanksgiving, we have a regular Tuesday and Thursday. And the following week, we have class on Tuesday. That is the last class. In other words, we have a total of 4 more classes. I'm going to be assigning you homework that will be as a review. I will be giving you, probably right after Thanksgiving, a practice final for you to do as well, so that you can try these examples and know what you need to know for your final exam. Remember, your final exam is 60% of your course. Again, anybody who has not completed all the work, go back and do as much as you can so that you can get the 40% that is classwork and tests. You should get as much of that as you possibly can so you can get as good a mark as you able to. Okay, have a nice weekend, and I'll see you on Tuesday.
You too.
You
Bye-bye.
too.